Hello everyone and welcome to the physics lectures. In this video I'm going to talk about vectors. The topics which I'm going to discuss are resolution of a vector, which essentially means how you resolve a vector into its components in x, y and z directions. Then I'll discuss addition and subtraction, and then the dot and cross products. But before we get into that business, we actually need to know what is a vector. So vector has two components, scalar and directional. Scalar part is the magnitude of the vector, while direction is specified with some coordinate system. So the most important part to talk about the vectors is a coordinate system. So suppose you have this vector v in a coordinate system of x and y. So I'm taking a two-dimensional system. You can take a three-dimensional system as well, but two-dimension is simple, so I'm sticking to that. So suppose you have a vector v which is given by vx in x direction, vy in y direction. Now I'm using x cap and y cap to represent the directions. People usually use I cap instead of x cap and j cap instead of y cap, but I'm using these for simplicity. And as I said, that a vector has essentially something called direction. So direction is specified with respect to an axis. For example, x-axis over here, so we need to have some angle, suppose theta, at which the vector v is aligned with respect to the x direction. So suppose we do not know the value of theta and we do not know the magnitude of this vector, then it is possible to find those out once we have these individual components vx and vy. So to do that, we can use very simple mathematics. As here you can see that this represents the magnitude of the vector v, which is nothing but the square root of vx square plus vy square, and this tan theta is given by the y component divided by the x component of vector in x and y direction, where we had this x direction, y direction and the vector v. And right here we have the angle theta. But this is when we already know these components x and y of the vector v in the direction x and y respectively. But suppose we do not know the components and instead we know the vector as a whole and the value of theta. Then how do we proceed? Then something called resolution of a vector comes into picture. That is how you resolve a vector into its components, and that requires the use of very simple trigonometry. You can see that the projection of this vector v on y is given by, suppose I call it vy equal to v sine theta, and vx, which is the component of v in x direction, is simply given by v times cos theta. Here this v is nothing but the magnitude of the v vector, and you can actually see that these two are related to one another. How? You can simply divide vy by vx and you will end up with tan theta equal to vy by vx. Now this resolution of a vector is a very simple yet very powerful tool, and this is used almost in all the fields of physics. And a very simple example is that of a block being pulled by a force F in some direction which is at an angle theta with respect to the x direction. So to solve these questions, you need to first resolve the force F in mutually perpendicular directions, that is in x and in y direction. So clearly, as in the previous example, you can see that Fx would be F mod of F cos theta, and Fy would be mod of F sin theta. And once you have Fx and Fy, you can use the equations of Fx equal to m of Ax and Fy equal to m of Ay. So this is just one example. There can be many. This is one of the most common examples for the resolution of a vector, and to give you an idea how important this thing is. And if you're still confused with how am I resolving this vector, it's very simple actually. You can just see the projection of this vector in this direction. This gives you the y component, and in this direction gives you the x component, which is this, and this Fy is this. If you like, you can pause the video and try to understand this very simple trigonometry, but you should take your time. Next, I'm going to talk about addition and subtraction. Suppose we have two vectors a and b, and it is known that the vector b is at an angle theta with respect to the direction of angle a. So in that case, you have this a and b, and the resultant is given by this vector, and I call it vector r. And now we are required to find out the magnitude of r as well as the direction of r with respect to the a vector. So the formula for the magnitude is given by a square plus b square plus 2ab cos theta, and the angle at which the resultant vector is aligned can be found out geometrically. As you can see that this angle phi, if you want to find out the tan of this angle phi, then that is given by this perpendicular upon this base. So you can just look at this figure and understand that this should be given by b of sine theta divided by a plus b of cos theta, where this b and a, these all are magnitudes of vector a and b. Now addition and subtraction are very similar, but there is a very small difference. Suppose you have again two vectors a and b, and on one hand you add a with b, and it is known that b is at an angle theta with respect to the a vector. And suppose in another problem you are required to subtract. So what I say is that if suppose r vector is given by a vector plus b vector, and suppose r prime vector is given by a vector minus b vector, then this is nothing but equal to a vector plus negative of b vector. So how would that look graphically? I suppose something like this. You can see that the b vector I have drawn with a dotted line because this is not what we want for r prime. So we have this a vector right here, and then we have the negative of b vector, and again you have the resultant r prime something like this. This is the r prime vector, and similarly in addition it was something like this. Here you have r vector. Now there you have the resultant vector something like this, and here in subtraction you have the resultant vector something like this, and I call it phi prime. Now the only thing that remains to do here is find out the angle at which minus b is aligned with respect to the vector a. So suppose you only knew that vector b is aligned at an angle theta with respect to the direction of angle of vector a, then minus b is aligned at this angle, which I call theta prime. Now it's not a difficult job to find out what is the magnitude of theta prime. So once you know theta prime from geometry, the formula for the resultant vector's magnitude is the same as that for addition. And again, for phi and phi cap, we can simply use the geometry and trigonometry. For addition, we already had the formula for tan phi, and to find the formula for tan phi prime, you can see in this figure that phi prime can be found by using the magnitude of this black dotted line and this length. Now there are two ways of representing a vector. One is the older way that I have been using, while the other is this, which seems a little more mathematical. Now if you have this kind of representation, then addition and subtraction of vectors becomes very simple. So suppose you have two vectors a and b with components a1, a2, a3 and b1, b2, b3. Then the addition or subtraction is simply given by this formula. Now you can see how simple this makes our calculations. And suppose you say that this is the resultant vector and this is the x component, this is the y component, and this is the z component of the resultant vector. Then the magnitude of the resultant vector is simply given by the previously used formula, which is the simplest form of magnitude of a vector. And if you want to find out the direction of this vector, then you should know that a vector is given by, suppose we have r vector, then the r vector is given by magnitude of r times the direction. Suppose I call it e cap. So to find out the direction, what you need to do is simply divide the r vector by r magnitude, and when we do that, we get the direction. So if you have this resultant and you want to find out the direction, then you simply divide each component, this rx, ry and rz, by this whole magnitude, and that should give you the direction. And in this case it would be given by this formula. Now I would recommend you to take your time and pause this video and try to understand how I got this result. And it's very simple, and if you have any problem you should comment. Next I'm going to talk about the dot product and the cross product, but you should know that these are very big topics, so here I can only introduce these. So one thing to notice is that the resultant of a dot product is a scalar, while that of a cross product is a vector. And the dot product is given by the product of the magnitude of A and the magnitude of B times cos theta, where theta is the angle between the two vectors, vector A and vector B. Similarly, the vector product or the cross product is given by the product of the magnitude of A and the magnitude of B times sine of the theta, where theta is the angle between the vectors A and B again. Now if you have the components of vector A and B as we previously used, where we had the components A1, A2, A3 and B1, B2, B3, then in that case the dot product becomes, as you can see, it is a very simple formula, and because you just have the product of magnitudes here, A1, A2, A3 and B1, B2, B3 are just the components, which are actually the scalars. So as a whole this thing is a scalar. Similarly, if you have components for these vectors a and b, then the cross product becomes something like this. Now I like to use this determinant form because this makes things quite simple, because the ultimate formula, which is this, is actually very hard to remember. So I use the determinant form and then find out the determinant, and I hope you already know how to find the determinant of uh, vectors. And if not, then probably I will make a video on the matrices, and there you can understand. Till then, you can just look into any book of simple mathematics and you will find how to find out the determinants. Now these dot products and cross products have many physical significances, so for now I'm going to only stick to this explanation, and I will make a different video for the two products where you will be able to get knowledge of everything related to dot product and cross product. Till then, thank you for tuning in.